Good morning, everyone. So, today we are going to discuss tutorial sheet 1, which is corresponding to all the topics which we have covered in chapter 1. So, there are 5 questions we'll quickly discuss. So, the first question says that how many labeled simple graphs exist on a given set of n vertices? So labeled word is important, which means that we know that in Kn the number of the edges are n minus 1 by 2. Yes. Now each of the edge is distinct if the graph is labeled, and each of the edge can be present, cannot be present in the graph. And this is why each edge has two choices, and in total there are n minus 1 by 2 edges, and therefore the total number of the simple graphs are 2 raised to the power n minus 1 by 2. Now the next is how many of them contain exactly m edges. It means that out of n minus 1 by 2 edges, we need to pick m edges, or we have to find the number of the ways in which out of n minus 1 by 2 edges m edges can be picked, which is c n minus 1 by 2 comma m. The next question is without using Howell-Hakimi theorem, prove that for every integer x, where x can have any value from 0 to 5, the following degree sequence is not graphical, which means whatever value you choose for x, there does not exist a simple graph for the given degree sequence. If we have to use the Howell-Hakimi theorem, every time we give a value of x, apply it, and we will see that in the end we are getting a negative integer, and that's why the simple graph does not exist. But if we don't have to use it, then we can see here that the order of the graph is 6, which means the maximum degree is 5. Now there are two vertices, let's say u and v, are of degree 5. It means that u and v are adjacent to all the vertices, to all other vertices. Yes, and if they are adjacent to all other vertices, it means that degree of all other vertices should be at least 2, but it is clearly visible that there is a vertex of degree 1, which is not possible. Therefore, whatever value we choose for x, the given degree sequence is not graphical. Show that there is no simple graph with 12 vertices and 28 edges in which the degree of each vertex is either 3 or 4. So to solve this question, we should use the degree sum formula. Please do try by yourself. So degree of each vertex is either 3 or 4, and there are total 12 vertices are there. So let's say x vertices are of degree 3, so 3x plus 12 minus x vertices of degree 4, and which is twice the number of the edges, which is 56. If we solve this one, then 3x minus 4x is 56 minus 48, which is 8. That gives you x is equal to minus 8, negative integer. So the number of the vertices cannot be negative, and therefore there does not exist such simple graph. Similarly, if you try the other one, you will find that the number of the vertices coming out to be non-integer, which is again not possible. This is a very interesting question which says that show that the number of the vertices in a self-complementary simple graph is either 4k or 4k plus 1. So you need to recall the definition of self-complementary graph. So let's say G is a graph and G complement is its complement. Then you must recall that the number of edges in G is m, and G complement is M dash, then it is equal to n minus 1 by 2, which is the number of the edges in the complete graph, because a edge is either present in G or it is either present in G complement, and that's why if you add these edges, now if the graph is self complementary, then your M is equal to M dash, which means that 2m is equal to n minus 1 by 2, or you can say that n minus 1 is 4m, which means that either n is equal to 4k or 4m or 4k plus 1. This is what we need to prove. So the most important part is this result which we have used for the complementary graphs. The last one says that let G be a bipartite graph with partite sets x and y such that the order of x is equal to 12. It means that order of y is equal to 10. There are 12 vertices in x, 10 vertices in y. And if there is an edge, then it has one endpoint in x and the other endpoint in y. Now it is given that every vertex in x has degree 3, while every vertex of y has degree 4. So this, how many vertices of G have degree 2? Now for the bipartite graph, let's say you have this bipartite graph. Draw whichever way you want. You can always observe here that if this is x, then the degree sum in x, which is here 2, 2, 4, 5, is always equal to the degree sum in y, because one endpoint, if any edge is there, it has one endpoint in x and one endpoint in y. Therefore, the degree sum of x should be equal to degree sum of y. Now, degree sum of x is every vertex has degree 3, so this is 36. And for degree sum of y, you need to find the vertices of degree 2. Let's say they are x, so 2x plus the total number of the vertices are 10, so 10 minus x, 4. This is the degree sum. And now if you solve it further, then 36 minus 40 is equal to minus 2x. That gives you x is equal to 2. So that's all from tutorial sheet 1. In tutorial sheet 2, there would be many more questions. Thank you.